infraction, right? So the thing is, if you make the laser goes through the cube, the square, so what do you think will happen on the light panel?
If we shine a laser through a little square like that?
A square like that. I can give you some.
We would make a big square on the other side?
So you make something like that. So they have a infraction this way, that way. Make a lot of squares.
Yeah.
And what will happen?
No.
It's just that one slide.
No, his computer hates him. Whoa, whoa. No. Oh no.
Someone will not get it.
We lost network connection.
And then if you make it bigger, so they have a light pattern. Make the whole,
make
the
hole
square
bigger.
Oh.
Yeah.
So you get smaller, yeah. You get a smaller pattern.
Yeah.
Oh.
So what will happen if you make it not the same length? This part of water is much shorter.
It should get smaller that way.
Yeah, small this way, big this way. You're right. If you rotate it some degrees, it's short, right? This part is wide, this part is short. You should guess.
So it's
just
opposite.
pattern.
What you think is
some degree. So when you pass a laser light through an APL, so you get some fancy stuff like that.
What do you mean APL? Like an opening that says APL like that?
Yeah, opens the holes so let them get through it. So the idea is, you said linear, you just think linear way, you just overlap different patterns together. This one is definitely wrong. So this guy, I should fix it. So the thing is, the A actually is made of 3 slits. So this one is single slit, this one is single slit, this one is single slit.
Right.
So this single slit give you a pattern this way, and this guy give you that way. This direction, this guy give you this direction. So this one is wrong, just ignore it.
So it would actually end up looking kind of like an A, except with a vertical line through the middle instead of a horizontal line.
Oh, this one's wrong.
Well, right. No, I'm saying what it would look like. You'd have one line like that,
you should get this
one line like that, and then one vertical.
One is line, one
yeah.
line. So there's 3 lines.
Okay.
So saying L is over here. You get this line because it's this slit. You get this line because it's slit. And then you just add them together.
Okay.
And this guy, you give some weirdness like that. So if you put them together, you just add them, all the patterns together.
Cool.
So this is one way to analyze what we have in the pattern that we have of interference or infraction kind of thing. Infraction. And it's what we did today. So it's a hole. So if you put a laser through a hole, we have you got a lot of range, right?
Yeah.
You got a lot of range, and this range, the area disk is the one you really care. You really you have interesting because this guy, the video of that can give you the information of the hole. You just let the light pass through. Yeah, and you make a square, you get something like a square. And what happens if you have 1,000 rows, 1,000 holes here? This guy is actually what we measured today.
Right, but it's a would this be contained in a larger circle pattern? Does it matter? Does it matter if all of these little circles are contained inside of a circle or a square? Would you still end up getting rings like that?
It doesn't matter.
Okay, yeah, we should get the rings.
So you have so many things, but the envelope is actually measured by the small ones. You already have in the previous slides, you already know that the smaller the thing is, the more various the infraction or interference is. So the small things really can determine the envelope of the light pattern. So you still get the same pattern, but because you still have so many rows, so many holes, so the picture is a little messy.
Yeah.
If you have so many squares, so you still get something.
Squares, but fuzzy.
Yeah, but it's fuzzy. So it's what we actually measure. If you measure like distance between this guy, distance between that guy, you will get something about this stuff. And for the holes, you can measure the radius of this guy, and you can calculate it, the radius of the.
You would learn the diameter of the little tiny circle. Yeah, interesting.
So if you even if you have 1,000 of them, the wave pattern still have the same envelope. So, but the more we have, the more worse, the worse the stuff looks like.
Cool.
So if you are random, yeah, the thing is they make it smaller.
So it gets bigger now.
It's like a bigger.
But fuzzier.
And if they are in pairs, then you can pairs.
Oh, crazy.
It's like double slit kind of thing. Multiple slits. You still have the same pattern, but they are made of some something like that. Just remind something you learn in a double slit. In a double slit, you get some minimum, maximum. So you still get something, but the pattern, you can see the disc here and some ring around it. So you measure radius from here to here. You can still get some information about the little holes. So the idea is, what you do today is you learn one thing is the envelope of the circle of the pattern is determined by the small ones. The most small ones you give the more various pattern. And the more the pattern, the more the hole is, the more the square is, the more messy the picture looks like. So this is like it.
Cool. The end?
The end. 所以。